Really great to see all you guys here. Today is a very special day in the Alumni Center events. You guys know that we've been talking about the Walk series for some time. This is the Voice of Excellence series where we get people who have made a difference, people who are making a difference, people who have excelled in their field to come and share their thoughts with us. I shouldn't be saying this, but I'll still say it. It is our own version of TED Talks where we will get speakers of eminence to come and share thoughts, their ideas with us. So it really gives us great pleasure to kick this series off, the first of hopefully many of them going forward with Rahul and Team Indus. This is a phenomenal initiative where one of the 5 chosen companies in the world racing to put the first spacecraft on the moon. Rahul will talk more about it in terms of the engineering effort behind it, the challenges in doing that, the prizes they have won, the awards they have won, and going forward, some of the unique aspects of where some other countries have participated with Team Indus. So, Rahul, welcome. Thank you for accepting our invitation. And I take this opportunity to invite Venkatachalam and Dhananjay also to be with us today. And really thank you for bringing a model, a replica of what will go on the moon. Thank you very much.
Thank you so much. Thank you so much, sir. Appreciate you setting me up so high that I'm not sure I'll be able to live up to the expectations, but let me give it a try. So thank you. This is about a journey that started a little over more than 6 years ago, and it's still work in progress. My short description is I describe myself as a yet-to-be successful entrepreneur. So I'm not necessarily qualified to come here and talk to you about how to be successful. This is just a story, and it's very light-hearted. We've thrown in a little bit of engineering here because we talk in the IIT, and why not talk engineering? So the next 15, 20 minutes, I'll try and keep it interactive, if that's okay with all of you. So this is about what you see on the screen is 2 of our engineers who are building a spacecraft. On one side, you see our rover. On the other side, you see our Japanese competitor's rover called Hakuto. So this is the story, and the genesis of trying to do something like this has to go much deeper. So I know we have some very young people here and some very senior people here. How any of you who was growing up in India in 80s and 90s? So any idea where you would have seen this on TV? Doordarshan 1. It was always on Sundays and it was 9 a.m. That was the only channel available at that time. But extremely inspiring to see Star Trek there. Interestingly, Carl Sagan came to our screens much faster than anything else, and this was him demystifying science, demystifying especially space for the rest of the world. And for me, growing up, this was one big inspiration. And when you listen to such people, when you are made aware of the beauty of the cosmos, of the universe, growing up, it has a lasting impact. So a little bit of the genesis of what I do today has to go as credit to some of these people. I'm sure everybody recognizes the person on the screen. So this is closer to time, and I'm sure our students right now in IIT would definitely recognize him. And I'd be surprised if you don't look up to him, because he's been one inspirational figure who has gone on and disrupted industry after industry after industry. Absolutely. So not to offend anybody here, but he's one person who made money and then refused to become a VC. He went back to being an entrepreneur again, then made money, went back to being an entrepreneur again. Probably the only person ever in history who's created 3 companies and is on the way to make the 4th company, each one of them $1 billion in value. It's very interesting, the things that are happening around us and opportunity to learn from them. Closer to home, this is quiz time. Any ideas what you're looking at on the screen? No. This is actually Mangalyaan. So not that you can make out the difference. They both look like a satellite. They were both 1,400 kgs. But yes, this is our very own ISAC. This is on the old airport road in Bangalore. And that's Mangalyaan being assembled before it was sent on its way. So just giving you a little bit of a background of what was going through my mind and all the folks who actually jumped into this to create this company. Just a little bit of background on that inspiration. Google is the sponsor, XPRIZE is the organizer, and it has a 2-line problem statement. Line number 1 states, before 31st March 2018, land on the moon, move 500 meters, send back evidence that you've done so. Evidence comprises of imagery data, video data, telemetry data, so on and so forth. Line number 2 states you have to do it while you're 90% privately funded. That makes the problem, a little bit more complicated than what the engineering problem originally was. Had it not been for the second clause, we could have, joined forces, gone to DST and said, give us a 500 crore check, and if it doesn't work, we'll give you a report which says why it didn't work. I'm sorry, I know I'm inside IIT, but that was Genesis, and that's why Google backed it, to say that, if you have to create disruption, you have to look at ways and means and create mechanisms whereby people do really think out of the box. That's how big space, big government, big defense companies have worked till date, which is they have a concept, they go to the government, it works good. If it doesn't work, so be it. You send in a report why it didn't work. So this is about really trying to put the ringer on anybody who picked up this challenge. A little bit more about this competition itself. This was announced in 2007. That's when the competition was announced. The registration closed in 2010. We were the last team to register. We were the last team, as in we were the 30th team to register in the competition. At that time, there were 50% American teams, 1/3 European teams, and one-off teams from China, India, Japan, Brazil, Chile, so on and so forth. Today, it's down to 5 teams. They're just left with 5 teams. We do not, for reasons I cannot state, give too much credence to the 2 American teams left in the competition. We are very mindful that the Israeli team left in the competition is a huge threat, and the Japanese are flying on board our spacecraft, so they obviously can't land before us. So this is a 2-horse race. It's just about 6 months out, and we need to pool our resources, put everything together in order to be the first horse out of the 2-horse race. So that's what this competition is about. Many times I've been asked, why take up something like this, or what was your background, and are you a scientist, are you an aerospace engineer, blah 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 blah. My answer is actually none of that. And if I were a scientist, if I were an aerospace engineer, there is no question that I'd pick this assignment up. I mean, let's be very, very clear about that. And my background is software, products and services. Quite like a lot of software folks here, I see Anant there. We always believe that, if you're given a problem statement, you roll up your sleeves on Friday, by Monday evening, you'll have the answer. Whether it is the customer pushing you, it's your boss pushing you. Over our extended weekend, we can solve any problem. So when I started this off, I thought, this is going to take a couple of years. It's going to take a little bit of money. We'll figure it out as we go along, find money for technology, so on and so forth. But, that wasn't to be. It's more than 6 years today, and we're still 6 months out. What was interesting is when you try and enter a new industry, and you've thrown with these keywords which says disruption and fail fast and fail quick. I mean, you hear this a lot when we talk about startups. But I think a lot of that is jingoism. A lot of that is just unnecessary chest beating. change or disruptive change is not necessarily about throwing out what exists. So what we have done is, you have to solve the same problems. It's just that you have to find a new way of solving it, and that's been our mantra from day one. Uh, when I'm asked the question, why do such a thing like this, I usually end up by asking the question back, which is, well, Elon Musk said, I want to build a rocket and build a rocket using my money. Nobody asked him that question. So why is it that we ask ourselves the question, but we don't ask folks in America the question, or folks in Europe the question, or Japan the question? So for some reason, this is the whole mindset about, the whole, which has, come down a little bit, the whole mindset about you need to be engineer, doctor, lawyer, and you need to find a job, and you need to keep doing that. So somewhere when we started, we said, this is about being the change. This is not about following, this is about leading. And to lead, there will be risk. There will be mortal danger, as in if we fail at any point in time, we're not even worth the paper on which our documents are printed. So it is about taking the ultimate risk. It is about standing up and saying, we're going to be the change, and we're going to be the change out of India. Just to reiterate, Team Indus is building a privately funded spacecraft, intends to launch it for the moon in the first week of March 2018, landed before the end of the month. This is an engineering feat that has been accomplished by only 3 superpowers before. Russia, America in the 60s, 70s, China as of December 2013, and we hope to put the Indian flag on the surface of the moon early next year. So that's the complexity that our team has undertaken right now. Engineering, I promised engineering, so we're going to move to engineering for a little bit. So what you see on your left is the rover that we're building. That's a replica. It's a true size replica. The material is sexier looking. The real material is all aluminum. So it's not as cool looking in real life, but this is a version of the rover that we are flying. She's about 6 kgs in mass. 2 feet by 2 feet by 2 feet is the dimension. Half a dozen cameras on board, 30 watts of solar power. Looks small, but could go over an obstacle of 15 centimeters. I know all of us complain about our roads, but try taking your car over a 15 centimeter obstacle. It will not be able to do that. So for us to design this rover, we had to go back to first principles. We had to go back to the bulldozing effect of small wheels and the traction and the size of the grousers and all of that. So that's kind of what it has taken to do something as simple as a small electric car. So even that needed a lot of effort that went into it. The next artifact that we're building is the spacecraft. It's 600 kgs in mass when it takes off. 2/3 of that is fuel, quite like any aeronautics application you'd see. Fuel comprises of a big part of your lift-off mass. This is about 9 feet in diameter. It's about 6 feet tall. It has about 300 watts of solar power and uses bipropellant fuel to power itself. This goes inside the nose cone of PSLV. And fits snugly onto the 4th stage. Anybody following PSLV launches? Any idea how many satellites it's launched in February this year? 103 and 4. There was a bit of a thing there, but it's 104. Reason is that 88 of those satellites were Planet Lab satellites, and each one of them was just about a kg or 2. Therefore, it was possible to launch so many. For us, this launch vehicle can't take even a kg extra, so it's just one single payload, which is our spacecraft with our rover on board. So that's the difference in our launch compared to the launches before. Kepler's laws. We could do a quiz here. I can see a few young people. We could run a quiz here on Kepler's laws. Not interested? Okay, I'm going to skip that for now. Not going to embarrass anybody. So what the launch vehicle does is it takes off from Sriharikota, I'm sure everybody's familiar with Sriharikota, off the coast of Andhra Pradesh. In 15 minutes, it goes to the perigee of its first orbit, marked here as G1, and goes away. It ejects the spacecraft. In the process of ejecting, there is a separation switch which turns the spacecraft on. So at that point, it is at the perigee over here. So that's when the spacecraft turns on, and then it's on its own, depending on the specific launch time. We could take anything between 3 to 4 weeks to go all the way to the surface of the moon. So all the communication, the navigation, the control system, all of that is built into the spacecraft. So therefore, we have about, I would say about 10 engineering disciplines, pretty much everything other than textile and chemical engineering, pretty much every other engineering. So we obviously have a flight computer, we have software programming, control algorithms, thermal, propulsion, structures, mechanisms, you name it, we got all of that engineering going into this one spacecraft. Once it lands on the surface of the moon, it can operate on the surface of the moon for 14 Earth days. Any idea why 14 Earth days? You've seen this presentation, Raj. I'm not sure that's fair for you to answer. So this is solar powered. A lunar day lunar day is 14 Earth days. 28-day lunar day, right? So that's half day and half night. So 14 Earth days is solar powered, and this can operate only when the sun is up. So therefore 14 Earth days, when it becomes night on the moon, it's a frigid night. It's minus 150 degrees centigrade. So the structures will survive, the mechanisms will survive, probably even the motors will survive, but the electronics would all die. So therefore the mission life on the surface is just about 14 Earth days once we get there. Secret sauce, and we're actually giving you a little bit of proprietary information over here. So the reason why people haven't landed on the moon, or spacecrafts or missions haven't landed on the moon, is because the last part of this mission is completely autonomous. Up to the point that you begin descent, there is always what is called as a man-in-loop. So if the spacecraft saw something, underperformed, overperformed, it would write home. Somebody at home will pick up that information, analyze it, command it to do something differently. But it's when you begin landing that the spacecraft is moving at 1.7 kilometers a second. It takes 1 second for signals to come from moon to Earth. Even if we sent it back instantaneously, by the time we sent a command back, it's moved away from where it was. So you don't want to be commanding a spacecraft from Earth if it is moving at 1.7 kilometers a second. So completely autonomous when it comes to control systems. There is no air, therefore we can't use parachutes. It has to use only chemical propulsion. What is the problem with chemical propulsion? The problem is you eating your fuel away, therefore your mass changes, right? Because the fuel is going away and your thrust remains the same, therefore your acceleration or deceleration itself changes. So all that control algorithm has to be built onto the spacecraft. The terrain is unknown, therefore you need to use computer vision to look at the terrain and figure out what is a safe spot to land, and then finally actually land at that spot. So this is, and I don't know if any of you were following the Mars missions, this is what was described by NASA as the 27 minutes of terror. This is the same thing. This is the similar thing that we'll face. For us, it's just 15 minutes of terror, because we just hope and pray that it lands. We will not know till after the 15 minutes are over whether or not it managed to land on the surface of the moon. Just one last slide. The Earth is rotating and the spacecraft is moving in one direction towards the moon. Therefore, we need to be able, for us to be able to speak to the spacecraft, we need to have a deep space network at two ends, opposite ends of the globe itself. Bailalu is 40 kilometers outside Bangalore. Goldstone is right outside LA, which is just about 180 degrees removed. So using these two main ground stations, we are able to speak to and listen into the spacecraft 24/7. We have backup stations in Madrid, Canberra, Bayak, and so on and so forth. So a lot of, beyond the engineering, beyond the fundraising, there is a lot of legal paperwork and international tie-ups that you need to bring into place in order to be able to do a mission like this. We did a, closed loop of the control algorithm. So that's what the camera sees as it is coming in to land onto the surface of the moon. We did a control loop simulation of this, and we used a robotic arm to simulate it. It's not a software, there's actual physical hardware. Therefore, we need to figure out if when the spacecraft touches down on the surface of the moon, what is the impact that would go back, what is the stress that would go back to electronics. So that's a drop test that we did back in December 2014. Subsequently, we've done a series of more drop tests over there to figure out if our design is working properly. Anybody builds machines out of India? Anybody who's developed products out of India, physical products? No. So while the design of our spacecraft is completely internal, the integration is internal, we'll qualify it completely out of India. Unfortunately, about 90% of the components that go onto the spacecraft are all imported. So therefore, we had to, import a lot of stuff. We had to bring all of it into our own facility and build our own assembly integration testing facility at our campus in Bangalore. So this was something that we were forced to build because there's a lot of export restricted items that were coming into us that were part of the spacecraft itself. What started off as a bunch of loosely connected people, were about, half a dozen people when we started off. We've grown to over 120 people today. You see Dr. Kasturi Rangan in the middle over there. He's been our guru Dronacharya, and he's been the mentor who was the voice of sanity. He's somebody who guided us on what to do first, what to do next. He introduced us to 24 retired ISRO scientists. A dozen of them today work full-time with Team Indus. They are the architects of what we are building today. So this is not just young kids reading off the internet. In fact, Dr. P.S. Nair, he's not there in this photograph, is an original recruit by Vikram Sarabhai. So that's how old experience we have working with us. He has the experience of having used hands to tighten bolts on a spacecraft to completely automated assembly that happens today. So that's the kind of experience that we have. We marry it with the energy of -1 to +5 years out of college engineers, and what you get is magic. So what 120 people at Team Indus do would take at least 500 people inside any other organization, not naming the kind of organization that this would compare to. Great validations along the way. One of the things that happened is that the Judges Institute a milestone prize. They came and looked at what we had built, and they decided to award us $1 million. The only revenue we've had over the last 6 years is $1 million that the judges gave us on account of verifying and validating all the technology that we had built. CNES is the French space agency. They haven't landed on the moon before. Their program to land on the moon is 2021, might get pushed to 2022. So they want to send cameras on board our mission. So this is the first time CNES is tying up with a non-European private entity ever. University of Colorado Boulder, they're giving us the ground control software. The last one is the logo of the Japanese team. They're competitors. They only have the rover. They do not have a spacecraft and do not have a launch vehicle. So we're carrying them on board our spacecraft, drop them on the surface of the moon, and then it is a race of who makes the 500 meters first. Very interesting media to watch at once we land on the surface of the moon. It takes a lot of money to put this together. We've had amazing support along the way. People who have come forward, I'm sure you recognize most of the people over here, so not going to name them, but R&T himself has been a huge supporter. In fact, he is one of the mentors of X Prize, and he's been a mentor for them for over 20 years. Nandan is one of our biggest backers. In fact, he's our backstop. When we run into trouble, we always run to him. Kiran came on board as a sponsor for one of the student experiments. Lakshmi has been a huge supporter. And I can tell you, we won each one of them in the first 5 minutes of our pitch. Anybody who had questions about the return on investment and how will this happen, we never managed to convert them. Each one of these conversions happened in the first 5 minutes of us talking to them and them believing that this needs to happen out of India, because this is the way that you truly create a new India. It's a big, expensive mission. Did I mention that the first prize for landing on the moon and moving 500 meters is $20 million? If I forgot to mention that, that's the first prize. It is the world's largest ever incentivized prize ever in the history of mankind, $20 million. Having said that, any guesses on how much this is going to cost us to do? A whole lot more than that. I can give that as a clue. 5 times thoda zyada ho gaya, boss. We'll settle for about 3.5 times. So this is going to cost us close to 500 crores to deliver. And for us, out of India, it still is the cheapest. It still is the cheapest that anybody could build this kind of a mission to land on the moon. To orbit the moon would have been relatively easier. You fly a smaller camera, fly a smaller satellite, and therefore your launch costs are low. So it's a fairly expensive mission, and despite all the really big names who are supporting us, we're still looking out for more support in order to be able to complete this journey for us. A big difference between Team Indus doing the mission to the moon and ISRO doing a mission to the moon is we own the spacecraft, we own the IP, and we're happy to open this up. We're happy to open this up, and I truly believe we managed to progress because we were always an open mission. We always allowed people to come in, contribute, support in various different manners, and that's why we managed to progress so far despite having very, very limited resources. So Har Indian Ka Moonshot is the name of our campaign. You'll start hearing a little bit more about it towards the end of this month and throughout to the launch. This invites all of you to come be part of what we're building. For me, as starting this off and saying, would I like to risk the next 5 years of my life and not knowing how far we're gonna go? The one thing that kept me alive throughout was the dream that if you build something and it's flying in space, you should be able to sit at a console like we see it in movies which say, Houston, there's trouble. Houston, can you fix something? So on and so forth. So to me, what kept moving me forward is the zeal or the interest to be sitting on that console. As we meet more and more people, we've noticed that that's kind of people want to come and see, people want to come and intern. There are lots of interesting ways to get involved, but the one thing almost everybody wants to do is be part of the command center. So we said, let's just convert that into a fundraising thing. So we're launching this campaign, and we're saying, if you come up and sign up with us for this campaign, we're going to make you a rocket scientist, and this is how we're going to make you a rocket scientist. 2 days before launch, a day before the actual launch, there is a complete flight readiness review, operational readiness review. There is this checkout that is done for the spacecraft, for the launch vehicle, and the integrated system. We're going to give you a behind-the-scenes view for that. We are going to set up 6 ground centers across the country, and you will be able to come to one of these ground centers and be able to experience everything that goes into the preparation of a launch of a spacecraft towards the moon. It's a little bit on the lines of, if you followed Formula One, listening into the pit crew talking to the driver. It's the same excitement, it's the same exhilaration as listening into what's going on in the background. NASA geologists use mixed reality to study where the Mars Curiosity rover is. What we're going to do for you to make you a rocket scientist is we're going to give you the same mixed reality experience with our rover on the surface of the moon. So all the simulation that we're going to do, everybody who comes to this command center will be able to walk next to the rover as it traverses a path, as it moves 500 meters, and so on and so forth. So that's another part of the experience of being a rocket scientist. Obviously, the launch. I think we all watch this on Doordarshan. There is a webcast. It's a few minutes, but we're going to bring this to you in its finest glory. We're going to bring this to you with the most amount of data that you have ever seen or heard or learnt about a launch. And therefore, each of these 6 command centers across India will get that experience over to you. there cannot be a Indian gathering without a little bit of Nachna Gana, whether it's a marriage or a conference. So we have an anthem. It's coming out later this month. Do watch out for that anthem, and we're gonna have a live band play this for you if you're part of this command center when we're launching for the moon. Interstellar, Martian, anybody? Anybody's not seen it? Is that a better question to ask? Okay, not going to embarrass anybody. So our spacecraft sends back about 450 different parameters, and I know that when you're watching a movie, when you're hearing about something, reading something, you hear about telemetry parameters, GNC, flight dynamics. You hear a lot of that. What we're going to do for you is we're going to demystify and break that down for you in much, much simpler terms. So 450 parameters crammed into 40 screens, and you can see about 4 screens over here, which will explain to you what is the need for that parameter. What do mission operators understand when a certain alarm goes off? What are the contingency maneuvers, and so on, so forth. So we'll give you that experience of knowing how a mission operation actually happens. Hidden Figures, anybody's not seen Hidden Figures? Not a very interactive crowd here, are we? So Hidden Figures is the story of divided America back in the early 60s when NASA was trying, when the Russians actually beat NASA and put Sputnik out there. So it's a story about, it's too overlaid story. It's a story about how African-American lady who's a maths whiz, she's discriminated against, she's a typist, but she ends up solving the control algorithm problem that NASA was facing. And then they were actually able to get a man into orbit. So the problem that she solves, she takes up a chalk, goes up, and because at that time you didn't have PPTs, you had to write on a chalkboard, she just climbs up and solves it. And when you look at that, you say, okay, looks like she solved something. What we're going to do is we're going to do an explain on that. What did she solve? How does it apply to us? How did we solve it? So that the whole thing about science fiction, we're going to just demystify what does it mean to look at some of these things. What does it mean to travel faster than light? How and if would that be possible? Not anytime soon, but we're going to give you, I'm sorry? Yes? FTL travel, go Google it, you'll find out. There's a lot of theories around that of how, so what you see in Star Trek, right? They say it's warp drive. It's going to warp drive, that's technically faster than light. You're going to travel faster than light, and there's a wormhole concept. So we're going to come back there and explain to you how could this happen when it happens in the future, right? It'll take us 3 weeks to land on the moon, so we're not going to keep you locked in that room forever. We're a startup. Unfortunately, we can't guarantee that we land on the moon. I think today we'll be at about 80% surety we can land on the moon. By the time we launch, we'll probably be 90% sure. So what we're going to do is everybody who is part of this crew will be given an app, and they will be able to see the landing. You'll never get this perspective, because this perspective means there's a camera on the moon before you land, which is not true. At least we don't have a camera on the moon before we land. So you'll never get this perspective, but the idea is this is history in the making. For the first time ever, private enterprise will get into space exploration and actually be able to make it happen. So for us, it's a race between the Israelis and us. We hope to have our noses forward when it comes to March 2018. I'm sure if you have younger kids, they love to drive electric cars and remote-driven electric cars. How about using a mobile app to drive this rover when it is on the moon? That's the ultimate prize for all the supporters who back us. And it'll be on your mobile app. We'll figure out how to poll who gets to drive the rover first. And once it's on the moon, you get to use your mobile phone to drive it. So that brings me to the end of my presentation. Let me leave you with this one defining thought, which a lot of people in this room would identify with, which is India is today a cricketing superpower, not because Dhoni hit a six in 2011. It's because the Indian cricket team won in the Prudential World Cup in 1983. There are a lot of similarities to be drawn between what Team Indus does today and the 1983 Cricket World Cup. It was a two-bit team. Nobody gave them any chance. They went to England. They beat the mighty West Indies twice in 2 weeks. And that was the genesis of India becoming a cricketing superpower. The ball was set into motion back then. To my mind, I have no doubt if Team Indus goes out there as a privately funded initiative, lands this rover and the spacecraft on the moon, the impact or the return on investment of this mission is on the minds of the entrepreneurs, minds of the next generation, and forever, nobody will ask the question, if the Americans are not doing it, why are you doing it? So that's it. That's Har Indian Ka Moonshot. We would like all of you to support this for us to be able to make this happen. Thank you. Happy to take any questions if there are any. Two or three criteria. So in the beginning, the 30 kept dropping out naturally. So, a whole bunch of them were startups. Some of them couldn't sustain. Some of them got acquired, so on and so forth. And in the end, there were, I think, 12 teams left. The organizer said, if you don't have a launch contract, I'm afraid you can't fly. So therefore, we're going to disqualify you. So as on 1st of January 2017, only 5 teams were left. A day before that, there were about 12 teams. Yes, sir. No, we're flying ISRO. We can't build a rocket. That's restricted technology. I wouldn't be allowed to speak in open public if I knew how to build a rocket. We're building the spacecraft. That's correct. Spacecraft, and this is the payload that goes inside our spacecraft. Yes, sir. No. We're sourcing for a lot of places, but not Israel for obvious reasons. Yes, sir.
The fact that we have ISRO in India, that was a very big boost. And there, and so on. You think that you have still managed to do it with external help?
No chance. This is truly, and I'm sorry if I did not use that in my presentation. This is truly about standing on the shoulders of giants. I don't think without an ecosystem we would exist. And in fact, that was one of the questions that I asked Dr. Kasturirangan in our first meeting, which was, how do you think ISRO will perceive Team Indus, which is in some manner of speaking competition? And given who he is and given how he thinks, his answer was very, very straight. He said, can a grandfather ever be jealous of the grandson? I mean, is that ever possible? So, and that was it. We never ask that question. I'm a little sorry to say that there are few people inside the system who do see it the other way, but pretty much I think we wouldn't exist if ISRO didn't exist, and we couldn't have paid Americans to come consult with us and help us design over 6 years. So we're an outcome. We're an outcome of the ISRO investment over 35 years. We are one of the outcomes, and ISRO should be proud of what we do. And actually, they have been supporting us all along. I thought there was a question here. We started off in Delhi, and the first advice Dr. Rangan gave is move to Bangalore, yahan se kuch nahi hone wala, which was true. We moved to Bangalore end of 2012, and we pleaded, we petitioned, we gave presentations, we pleaded, we petitioned, we gave presentations, then we started praying. After 3.5 years, they gave us a launch. Having said that, it was a long process, and launch capabilities, it's a supply constraint industry, and they had to be sure that they're giving it to somebody who knows what to do with it. So it was a long process, but we're delighted that we have one of the launch vehicles with our mission name on it.
This competition has been sponsored or rather been proposed by Google. What is it?
It's sponsored by Google. So Google pays two things. First, it sponsors the money the prize money that'll be won is paid by them, and second is they pay for running the competition, which is also a few $1 million every year. It's now more than 10 years old, so I'm sure they put in a lot of money. The simplistic answer to your question is that Google is a media company. The media that any of the teams generate on the mission is royalty-free for them for life. That's one part. The second part is Google sees this as their first entry into space as a market. When will it come true? Will it come true? I'm sure in 2007 they thought that it'll come true in 2, 3, 4, 5 years, 10 years already. And we're still saying there's some distance to go. So for Google, I think it was creating disruption, backing something which is new, and actually seeing it go through. Yes. We're funding this using 2, 3, 4 different buckets. So one bucket was equity. So we diluted a fair amount of equity in our company to get money in. The second bucket is selling payload, our ability to deliver something to the surface of the moon. That's how we got the Japanese on board. They're paying us to carry that rover to the moon. Not a lot of money, but some money, which helps. The third bucket is we're looking at corporate sponsors. And the final bucket is what I was talking about, which is technically crowdfunding. A lot of people coming forward and saying, if I give this money to you, what can you give back to me in return? And we're saying we're going to give you an experience that money can't buy. So those are the 3, 4 buckets that we're using to finance the mission. Yes, sir.
Google's competition is to run 500 meters on the surface of the moon.
That's correct.
The competition is not about, as I understand from you, is not about building a spacecraft that lands on the moon. There's no points for that. And the Japanese obviously have taken advantage, saying we're not going to build the spacecraft.
We're not going to take that risk. That's correct.
Yeah. So
technically, they could win. Technically, both of us land. Technically, the Japanese could win.
Yeah. No, it's not just winning. I mean, it's also about all the effort and all the money that you're raising. So do you think it's been worthwhile to build a spacecraft along with the rover?
Absolutely. And I'll go back to the 80s and 70s and 80s. And if you remember, I mean, we had this in our textbooks, and this was a classic example. I'm sure a lot of you might remember that, which is we mine iron ore from Jharkhand, we put it on a ship, send it to Japan, and Japan makes steel and sends it back to us and sells it to us at 1,000 times the original price. You remember this from 80s? I mean, it was a common thing in our textbooks, and kids would be taught that. You know what? 30 years later, that has been inverted. And I'm not saying I'm doing it the first. And I know a lot of you are probably working in companies, building products where that has been inverted. Today, India can value add on top of the input that Japan gives. I'm taking greater risk, but I'm also building greater capability. They're building a small electric car, which is going to work on the moon, great, but what is the outcome or what is the learning for them? So we're taking a greater risk, we're raising a lot of money. We do potentially stand the chance of losing the race, to which, you know, there are conspiracy theories of, because the communication is through us, if need be, we can shut the communication down for a little bit. I didn't say that aloud, did I? No, I didn't say that on record. So, you know, having said that, I think I see ourselves as the platform provider of delivering payload to the surface of the moon, for which we're going to get paid on our beta launch. I think that's great for a startup. Even if it is less money, even if the customer ends up looking good, so be it. I think it makes us look even better. So that's been our thinking. Thank you.
Thought about the way beyond March 2018 as the team in this motivating.
Sir, I'll go back to saying that I don't think Elon Musk thought, what will I do after I launch my first rocket? So, well, that's my first answer. My second answer is the only thing we thought of, and you know, I'm being forced to commit to, is 30 days paid vacation after the launch. I've not signed off, and I'm not sure our investors will like that. But on a serious note, 120 people under one roof. I think we've got serious capability under one roof. It's very rare to have this kind of capability under a single roof. It's very rare in India. It's very difficult to find internationally. So we see ourselves in the mold of building complex engineering programs, not a product, not a satellite, not a rover, but programs because we built this from scratch. We learned it the hard way, so we know everything we built from scratch. So we see ourselves as an organization which could go out there, work with international governments, work with large corporates who want to use space for their own business, for their own purposes. And you know that we rely on space every day. What are the two services from space that you use today? No? Which communication? Which are the two space-related services you've used today, each one of you? First is GPS. Good. What's the second one? How many of you have a cable wala? You don't, na? All of you have DTH. It's direct to home from a satellite, na? So space is infrastructure, and that's one of the reasons why India launched that SARC satellite, because it's infrastructure for all SARC countries. So space is infrastructure, and infrastructure you don't notice till you hit a road bump. Till then, you won't notice the road is good till you hit a bump. So you notice infrastructure in its absence. So we see ourselves as program owners, program managers, who can then subsequently work with customers who have the need and deliver on it as a program, not as a build to print or a job provider, so on and so forth. Yes, sir. I'll have to call an engineer to explain faster than life. Don't ask me to explain it.
Is there any component in this which is not made in India? Whether it is a chip or whether it's the tiniest
Everything.
component?
Everything. If I were to show you my propulsion system, it has tanks which are made in Europe. It has engines which are made in Japan. It has electronics which are made in America. The aluminum pipes. You have a geyser at home? You see aluminum pipe coming from there and going in there, right? You know SP Road in Bangalore? The aluminum pipes are from SP Road. It's the same aluminum pipe, steel pipe in fact. So the aluminum is Indian, the steel is Indian, the nuts and bolts are Indian, but pretty much all the electronics is imported, and which is why I was asking the question, if you tried building a product out of India, you'd realize that you're sourcing from a multinational each time. Each time, Texas Instruments, Atmel, you name it, they're all multinationals. I think on the rover we get a bunch of stuff. On the rover that we take outside to display, we take a bunch of stuff. But on the spacecraft itself, no. We have a bunch of stuff coming from Japan, but not from China. Yes, ma'am. The real honest answer is serendipity, and that usually is the answer for a startup. And I can tell you that any startup founder who says no, it's something else, he's lying. But having said that, I thought we had a force which was working with us, which helped us, and people would come, apply on our website, and we'd get about a dozen resumes a week, and we'd end up hiring one of them who fitted the bill. Quite like any other startup, we hired fresh out of college. In fact, we hired guys who were still in college. So Karan was still studying at SRM, and we forced him to write to his principal saying, I want to do the last semester at Team Indus. And the principal didn't understand what Team Indus is, but somehow we managed to make that work. So he did his last 6 months at Team Indus. He's the main engineer behind the rover. So all the design that you see on the rover is by him. That's Dhananjay. Karan is his batchmate. Karan is not here today. But it's been a very interesting journey. And no, we didn't follow any set formula. What we always knew is we will need the experience and we'll need the energy to find a new solution. If you got only young people, they'll probably be tying a helium balloon to this and trying to send it to the moon. If you only got ISRO people, then they'll follow exactly what they did at ISRO. Therefore, you had to come up with a new mix. There is a second prize, $5 million. Whoever finishes 500 meters, and the judges adjudge them to have finished. No? You define it. So we as delivery providers will drop the Japanese rover on the surface of the moon 1 second before us. Because that was one of their concerns. I'm sorry? I didn't follow. Oh, we supposed to take off in the first week of March, and I'm sorry. Israelis, we don't know. We don't know. We don't know. It actually doesn't matter to us. Yeah. And irrespective, I think although the genesis was the prize, at some point we said it's not about the prize. How does it make a difference? How does it really make a difference? We're still going to the moon. It's a privately funded effort. We're carrying the Japanese with us. How does it make a difference? We'll still go. Yeah, absolutely. Absolutely.
Question. From whatever I've read, when the US did a lot of these missions and learnings that came in out of these, and used in a lot of the work that goes
Yes.
on actually gets committed. Some of the work that we pick up on the way in terms of digital knowledge, what it does.
Uh, I'd go back to the cricketing analogy, which is, I think there's a lot of knowledge that we've got, less resources, less time, try and build something which is reliable. And but the biggest outcome is the fact that this can be done out of India. So the biggest outcome is the mental or the cultural change. And that's what I meant by cricket, that it's not as if Amarnath is still playing, he's not. But the fact that he was able to go in there and a medium pacer could take wickets and be valuable, all that was a trigger for industry to do more, as in more people to emulate and follow that path. So there's a lot that we're doing. There's a lot that some of our partners are doing, and then they are allowed to go ahead and continue building on that. So I hope a lot of IP comes out of it, but my expectation is a lot more people will come out and say, we're going to do something which the West hasn't done, or we're going to lead our way in a completely new direction. There's a fair amount of engineering data, and those are the 450 parameters that I was talking about, which is heat, radiation. A lot of that data is something that our spacecraft will collect. The rover itself has very limited sensors, so it will be able to collect terrain data. We were thinking of flying a small lab on chip to do soil analysis, because apparently now it is said that probably there is water all over the moon. It was previously thought there's no water, then they thought it's on the poles. Now they're saying there's probably water all over the moon if you were to go a little below the surface. But it's too late in the day for us to put a drill into it. It's too light. It won't manage the drill on its own. But yes, we'll have a whole bunch of data which is useful from a localization perspective. But will this completely fundamentally change the way that we look at moon? No. It's one of those efforts that is complex enough. We're going to try and make this land there and try and get the initial set of data. Great. Yes, sir.
Why, is there any reason Elon Musk is not competing with you? Or he was not allowed to compete with you?
No, he was allowed. It was an open competition. Anybody could have registered. But I think Elon Musk already had a company. In fact, he was one of the original partners for the competition. And he said, if anybody wants to go and they want to go on a SpaceX rocket, I'll give you a 10% discount. That offer still holds. So he was focused and concentrating more on the launch vehicle as opposed to the spacecraft part of it. "800 kilometers at the perigee of the launch." So that's where the launch vehicle goes, and it goes away, and the spacecraft separates and then continues on its journey to the moon. We chose the easiest spot possible. Yes, so there's open source data on the terrain, on the digital elevation maps are available. I'm sure the Americans have greater resolution. We have lesser resolution in the open domain. We were able to look at it and say, where are the slopes relatively gentle? So the landing site has maximum slope of 11 degrees. It is relatively crater free, and there are no big tall mountains or gorges. So it was difficult enough to put all this together. We didn't want to add risk to the landing itself. So therefore chose a relatively benign site. That is correct. That's chemical rockets. There's a hypergolic, it's liquid propulsion. So there's an oxidizer and a fuel. The moment they come into contact, there is an explosion, and that's what creates the thrust, and therefore your mass is reducing because you're consuming your own fuel. It's a completely soft landing other than the last 5 meters. So when it comes like this. It comes on top of the landing site, and the engine's cut off here. The last 5 meters is just drops. So that was a test that you saw, which is we were emulating or simulating how it'll behave if it were to drop from a 5-meter altitude on moon. That's gravity is 1/6 on the moon. Therefore, over here you drop it from 1/6 height. So we dropped it from about 1.2 meters height on Earth to see what is the stress that it experiences. It bounced back. If you saw the video, it bounced back. So that was the input to our design, and we had to change the leg design. So this is an older design. When you see a new design, the shock absorption system has been modified. Yes, sir. We could do Kepler's laws. Yes, sir. No. So it's not 1 second before landing. The spacecraft lands. Then there is a 2-hour cool-off period because we want dust to settle. We want to do a post-touchdown checkout of all the systems, prepare it. There is a new antenna that comes on which can beam higher bandwidth data. And after that, the rovers are deployed. We're just saying we'll deploy them first. It drops from a height of about 30 centimeters. On the moon, that's even less, right? It's dropping on sand. And 1 second later, we drop ours. So that's our commitment to them, that just to ensure that you don't think that we let you start the race later, we're going to let you start the race sooner. Yes. I don't think if I went to ISRO for a spacecraft, they would give it to me, because they don't have a spacecraft right now which can carry me to the moon. And if there is a launch vehicle going, so any student satellite is usually launched in a launch vehicle which is launching other satellites, and you put a small student satellite in that. So you're piggybacking. But our rover is 6-7 kgs. I don't think ISRO would take us. First point. Second point, we really wanted to build this capability and a little bit of capacity that holds us in good stead going forward.
1 second lead time, is that a disadvantage?
Our maximum traversal speed is 3 centimeters per second. Our best simulation suggests it'll take us 27 hours to finish 500 meters. So 1 second is not going to be too big an advantage for anybody there.
Would you like to speak about how the schools are getting engaged?
Yeah, absolutely. And we're doing a whole bunch of outreach activities, and any of you who are working with the foundation, have CSR obligations, Venki, we can leave his contact information here. Please do get in touch with Venki. He runs our foundation, Team Indus Foundation. We have a bunch of student experiments which are going on board. We're building a student satellite, a lunar CubeSat, first time ever in the world. It's a CubeSat built by students which will be put into the moon's orbit. Never before has that happened. We've had a bunch of student satellites into the Earth orbit. And the third program is Moonshot Cadet. So we the same software that we use to build our trajectory and the 2 orbits around Earth, Slingshot to the moon, we are going to take that to deserving students and train them on that. It's an intensive 1-week workshop. We're happy for students who want to volunteer, give time, learn from us, become the trainer going forward. So we've many such initiatives going on. In the limited time, I've not been able to touch on a lot of them, but follow us on social media. Just Google Team Indus. You'll find us on Facebook, Twitter, Instagram, and you'll be in touch with the announcements that we're making there.
fired. I don't know whether he's going to be impressed enough to hang out and come back.
Are you getting any support from the government?
Yeah. Well, yeah, absolutely. So first and foremost, I think the whole thing about this would not be possible if the government didn't, in a manner of speaking, allow it to happen. So that's the first part of the answer. The second part is, there's a cautious government, and you wouldn't want to overtly back something that you're not sure about. So I think we've been put through the fire a little bit, and we expect to come out on tops. I think there's a lot of support which is going to come from the government, but I don't want to prejudge any of that. So it's going to happen. It's going to happen soon. Yes, sir.
This forerunner, does this be a forerunner for, say, a manned mission later on through your company?
If we find the entity which wants to fund that, happy to do that. And in fact, that's one of the the extra programs that we have been thinking about and would probably start picking up, because for India, China has sent people in space and they have their own lab in space. For India, I think quite like every other endeavor, ISR is gonna do it on their own. So we'd like to see if we could run parallel to them and build certain technologies, build certain know-how, and then potentially give it to them.
Once people get into the project, the work gets easier, the flow gets easier. But then, what are the challenges that you face to get these people in, as in your initial days?
So initial days, as I said, there is a much bigger meaning to it, and the meaning is a little more than what's the salary I'll get or how will this look on my resume. So I think there's a far bigger meaning to it. In fact, I joke with a lot of younger ones to say, for me it's all right. I'm middle-aged and I have lesser time to go in my career. But if you're 24 and you built a rover which has landed on the moon, you'll have to struggle to beat that for the rest of your career. Right? That's so it's a bit of a Michael Phelps situation. The first time he's at Olympics, he wins 12 golds. Now, how does he beat that? Next time he comes 13, next time 14. In the end, he says, "Acha yaar, main thak gaya. I don't want any gold." So a bit of a situation like that. So, I kid with Karan all the time, Nirmal, Guru, all these guys. So I think there is that deeper meaning associated with what we do. And that's above the money that is in it. It's above time with family. It's above a lot of different things. Whether it should be that way or not, I'm not commenting, but it is. It has a far deeper meaning. So I think that's what attracts a lot of people to come work with us. We use fancy Star Wars names as designations, and we do a whole lot of fancy stuff that keeps them interested, despite all the pressure that they're working under. So until recently, we didn't have too much of attrition. I think we now 6.5 years. Our first set of employees have started completing 5 years, so we have to worry about gratuity. You won't know what that is. Other people would. So we started as a startup. It's an interesting juncture to be at when you have to start worrying about gratuity. So I think it's the meaning that attracts people, and the fact that we have been able to make progress, and we have a good shot of actually going all the way. What discourages them is the fact that it's very frustrating to have to hurry up, get ready, and then to wait, which is what has happened with us a few times because of delays in terms of the ecosystem, delays in terms of licensing, not getting into all those details right now. But we've met a few times we've hurried up, gotten ready, and not been able to do what we wanted to do. Great.
ISRO obviously is charging money for taking your spacecraft, right?
Yes, a lot of it.
That's what I want. It's a lot.
Yes.
Okay.
I'm legally bound now to tell you the number. It's a lot. Great.
Challenges isn't ISRO sharing the knowledge in such
No,
private missions?
as I said, Dr. Nair is an original recruit by Vikram Sarabhai.
No, the government, there's nothing barring them to.
Well, not really. I mean, 1 year after retirement, your this goes away, and then you are essentially sharing information which is dated. So it's not about the information. It's not. We don't want designs. We want the process by which you design, because we don't want to copy what you did there. We want to be able to start with first principles. Here's my requirement. If it is a 6 kg rover, it's a different requirement. If it is a 12 kg rover, the requirement is completely different. It's not as if I could just multiply by 2 and use the same material, same design, same process. So we want the process. We've got the process. We've got the experience, and you should look at the new spacecraft that we have in our Bangalore facility. It's technically ready to fly. Having said that, that's not the one which is going to fly. We're going to create a replica, and that's the one which is going to fly end of this year. Yeah.
So why is your traversal speed so low? Like it's only 3 centimeter per second. And one more thing is it autonomous traversal or manual control? The 500-meter traversal on the moon.
Are you part of any of the robotics clubs at IIT Madras?
We make a rover actually. We make a Mars rover in under C5.
Okay. What is the terrain that you use?
It's a Martian terrain. So there's a competition.
What do you use for the terrain? What's the material you use for the terrain?
The wheels you're talking.
No, terrain.
Okay. So we use our ITM's the forest area for present testing, but we have a place called MDRS, Mars Society. There's a place called Hanksville in Utah, which is where Curiosity was tested. So our competition happens there. So we should be able to make a rover ready for that. So,
Correct.
but our velocity, like our relay velocity, can go higher.
How
It's
much?
far. It can go up to 100 RPM, the wheel velocity. So the linear velocity can be quite high.
Convert that to meters per second.
Uh,
Then convert it to kilometers per hour. I mean, this is a pop quiz. Come on, guys.
but I'm sure it'll be more
Never
than
mind.
3 centimeters per
Just
second.
to answer your question, so first part of it is that the Martian terrain, lunar terrains are different. Lunar terrain is primarily sand, and we have a simulated mechanically equivalent sand that we use, which is essentially stone dust. So it's 150 microns, the biggest grain size. So when you're that, it's like talcum powder. If you had talcum powder on the floor, how fast do you think you'll be able to traverse forward? And if you moved faster, would you end up digging yourself in? That's one part of it. Second part of it, to optimize, we have skid steering. Therefore, we have to be able to turn wheels differentially. And if we try to do that any faster, you'll end up digging yourself into the soil. So, we went through all of those. Technically, we could put this on the ground, make it run, a meter per second or 2 meters per second, but on the real surface, it'll move much slower. Because you asked me that question, I'm going to give you and I'll let you use your phone. So, and I'll move to the next question and then come back. So give me the land traversal distance record, which mission holds it, and what is that distance on an extraplanetary body? Let's see how long you take to come up with that.
It's curiosity, right?
How much?
I don't know. It went on.
Curiosity is wrong. I'm talking about total record, total distance traversed. Who holds the record today and who held it before this? It's not opportunity. No, 5 centimeters is talking about the speed. Yes. So it was the Pathfinder, which did about 11 kilometers in 11 years. So it's not usually about speed, right? So it's 11 kilometers, 11 years. The record prior to that was held by one of the Lunokhod rovers. Lunokhod is a Russian mission, and they did about 10.6 kilometers in 2 years or something like that. These were all nuclear-powered rovers, therefore they could continue working day and night.
Yeah, and also is traversal autonomous, the 500-meter traversal? Or?
No.
Okay. You guys
it's complex
steer it?
enough. I'm sorry?
You guys control it?
Yes, it's man in loop. That is correct.
Okay.
How do we give people the opportunity to drive it from their mobile app if it is autonomous?
You give opportunity in that 500 meter.
Not after the 500 meters. We need to win some money, boss. After the 500 meters, you can drive rovers on the moon. democratic driving of rovers on the moon. Great. Sir. I think we'll wrap up if there are no further questions. Great. Thank you so much. I'm the fleet commander at Team Indus. Yeah, so that's a very interesting fact that I wanted to share, which is because space is like unknown terrain. So what we follow over there are the rules of international waters. International waters is 15 nautical miles beyond India's borders. Anybody can come and stand there. It's open. Any sovereign entity standing there, it's a diameter, a radius of about 250 meters around that is sovereign territory. So any of the Apollo landings, a diameter of 250, a radius of 250 meters around that is sovereign American territory. So I'll leave it to your imagination of where the next Indian territory is going to come up once we land on the moon. Great. Thank you. Thanks a lot.
So I think it's been one of the most exciting 60 minutes that we've been through. Thank you very much, Rahul and Team Indus. Rahul, once again, on behalf of the center, we would like to present you a small memento as a token of our... Rahul, can I have you back, please?